understanding Shannon entropy in a simple terms. In our everyday lives, we often encounter uncertainty, whether it's predicting the weather, deciding what to wear, or choosing a movie to watch. We constantly grapple with unknowns. Information theory, a branch of applied mathematics and electrical engineering, helps us quantify and understand these uncertainties. At the heart of this field lies a key concept known as Shannon entropy. So, what is Shannon entropy? Shannon entropy, named after the mathematician Claude Shannon, is a measure of uncertainty or randomness in a set of values or outcomes. It allows us to quantify the amount of unpredictability or surprise involved in a random variable. If you think of it in a simpler terms, Shannon entropy tells us how much information we can expect to gain what or when we learn the outcome of an uncertain event. So why it is useful? It is because a data compression. When we send or store data, we want to use it as little space as possible. Shannon entropy helps us determine the minimum number of bits needed to represent that data efficiently. For instance, if you have a long string of text, understanding its entropy can guide you in compressing it without losing any information. So, cryptography. In the realm of security, high entropy means that a key or password is hard to guess. The more unpredictable a password is, the more secure it is against attacks. So, Shannon entropy helps assess the strength of various keys. So, machine learning and statistics. Shannon entropy plays a crucial role in various algorithms, particularly in decision trees, where it helps in determining the best splits based on how much uncertainty the split reduces. Putting it in a perspective, let's illustrate Shannon entropy with a simple example involving a coin flip. Fair coin. If you flip a fair coin, the outcome can be either heads or tails, both equally likely. In this scenario, you have maximum uncertainty, one bit of information, because you can't predict the outcome with certainty. The entropy is the highest here because each outcome is completely random. Biased coin. Now consider a biased coin that lands on heads 90% of the time and tails only 10%. Here the uncertainty is less because you can predict that if the coin is flipped, it's very likely to come up heads. The entropy is lower than that of the fair coin, signaling less unpredictability. With certainty, if you had a coin that always landed on heads, the uncertainty disappears completely, resulting in zero entropy. There is no surprise at all because you already know the outcome. So, measuring entropy. Mathematically, Shannon entropy H is calculated using the formula, that is H of x is equal to sum I. This is the formula where p x of I underscore I is the probability of outcome x underscore I, okay, and then n is the total number of possible outcomes. The logarithm base 2 implies that the measured entropy is in bits. The outcome of this formula gives a numerical value representing the average amount of information produced by a source of data. So, everyday examples. Weather predictions. If a weather forecast claims there is a 90% chance of sunny weather and a 10% chance of rain, we know the outcome is largely predictable, resulting in low entropy. If the forecast indicates that there is a 50% chance of sunny weather and 50% chance of rain, the uncertainty increases, leading to higher entropy. So the text characters. In a text document, the letter E might appear more frequently than other letters. The entropy calculated from the distribution of letters will reveal that some letters provide less information than others as they are more predictable. So concluding everything, Shannon entropy is an elegant and powerful way to measure uncertainty. It provides insights not just in the information theory but across various fields like computing, statistics, cryptography. So understanding it helps us make informed choices about data management, security, decision-making process in a world full of unpredictability. So next time you feel uncertain about an event, remember that Shannon entropy is here to help quantify that uncertainty, shedding light on the unknowns in a structured way.